Welcome back, everyone, to another deep dive. This time, we're exploring something I find super fascinating, fine-tuning large language models.
LLMs?
LLMs, you got it.
Yeah.
These are those powerful AI systems that can write stories, poems, even translate languages and answer your questions like in a remarkably human-like way.
Right.
So we've got a bunch of sources this time that are really all about how to specialize these LLMs even more, making them even better for specific tasks that we want them to do.
Like taking someone who is really knowledgeable in a broad range of subjects and giving them specialized training to become an expert in one particular field.
That's a good analogy.
Yeah.
So we start with this LLM that has this kind of broad base of knowledge, and then we need to tailor it to a specific task.
Right.
So how do we actually do that?
That's where this idea of fine-tuning comes in.
Okay.
So imagine you're trying to teach the LLM to be like a sentiment analyst, able to determine if, let's say, a movie review is positive or negative.
Yeah.
You'd fine-tune it by giving it a bunch of examples of movie reviews and then tell it, hey, this one's positive, this one's negative.
Oh, so we're giving it labels.
Yeah, exactly.
Yeah.
And then it learns from these examples and it kind of adjusts all its internal parameters so it can accurately classify newer reviews that it's never seen before.
So it's kind of like, I don't know, training a dog with treats.
Yeah.
But instead, we're using data to kind of reward it for making the right connection.
That's a good analogy.
Okay.
But there are some challenges with the traditional way of doing this fine-tuning, where we update all of the model's parameters.
Okay.
For starters, it's really computationally expensive.
Yeah, I imagine.
These LLMs have millions or even billions of parameters.
Oh, wow.
So adjusting all of them requires a lot of processing power and a lot of energy.
Right. Yeah, for sure. And especially for, smaller researchers or developers who don't have access to these massive, computing farms and stuff.
Exactly.
That could be a big problem.
Yeah, and there's another issue, too.
What's that?
Catastrophic forgetting.
Oh, is that like when you cram for an exam and then forget everything else?
Exactly.
Wow.
When you update all the parameters, you risk the model forgetting some of its general knowledge as it becomes hyper-specialized in this new task.
So we need to find a way to make it more efficient.
Yeah.
So we don't break the bank and, turn them into like single-minded robots.
Right.
So that's where I guess PEFT comes in.
Yeah.
Parameter efficient fine-tuning.
Exactly.
And from what we've been reading, this is all about finding these kind of clever shortcuts to fine-tuning LLMs without having to update every single parameter.
That's a great summary.
Okay, good.
And the beauty of PEFT is that it not only reduces computational costs, but also reduces that risk of catastrophic forgetting.
That's great. All right, so tell me more about how this actually works.
Sure.
What are some of the techniques that researchers are using to make this more efficient?
Well, one of the most popular and exciting methods is something called LoRA.
LoRA.
Short for low-rank adaptation.
Oh, okay, so break that down for me. So LoRA is based on this idea that those massive white matrices inside these LLMs actually have a lot of redundant information.
Okay.
And the essential information for fine-tuning is often hidden in a much smaller space.
So instead of searching through every book in a giant library, we can use like a card catalog to tell us where to go.
Exactly.
Okay, so LoRA is like a card catalog for the LLM.
Precisely.
Okay.
Instead of updating the entire weight matrix, which can have billions of parameters,
Right.
LoRA injects these smaller, lower rank matrices that capture the information for fine-tuning.
Okay.
It's like adding a few strategically placed sticky notes with key insights instead of rewriting entire chapters of a book.
That makes a lot of sense, and it sounds incredibly efficient. So what kind of real-world impact does this actually have on the fine-tuning process?
Well, the researchers who developed LoRA, they applied it to GPT-3 175B, which is one of the largest language models available.
Right.
And they found that it actually reduced the number of trainable parameters by 10,000 times.
It's
incredible.
It's amazing.
What about like the GPU memory requirements?
Yeah.
Because that can be a major bottleneck
Yeah, for sure.
when working with these massive models.
Absolutely.
So did that help with that as well?
Yeah, so LoRA reduces the GPU memory needs by 3 times.
For GPT-3?
For GPT-3 175B, yeah.
Wow.
So this means you can actually fine-tune these really powerful models on more readily available hardware,
Okay.
which really opens up a lot of new possibilities.
So it's almost like we found a way to hack the system and make these LLMs work smarter, not harder.
You could say that.
Okay.
But the efficiency gains aren't the only benefit of LoRA.
Oh, really?
There's another feature that makes it really attractive,
Okay.
and that is the swappable nature of those low-rank matrices.
Oh.
You can train different matrices for different tasks,
Uh-huh.
and then you can just easily swap them in and out as needed.
So it's like having a toolbox of specialized skills.
Yeah.
You can just plug them in and out
Yeah.
depending on what job you're trying to do.
Yeah.
Exactly.
That's incredibly versatile. But how does it actually perform compared to, the traditional full fine-tuning?
Right.
Can it really achieve the same level of accuracy?
That's where it gets really interesting.
Okay.
Research has shown that LoRA can not only match,
Oh, yeah.
but even outperform full fine-tuning in some cases.
Really?
And it does all of this while using just 2% of the trainable parameters.
Wait, so we get better results with less resources?
Yeah.
That's pretty amazing.
It's really cool.
It sounds like LoRA is pushing the boundaries of what's possible
Yeah,
with LLMs.
for sure.
But before we, get too carried away, are there other PF techniques out there?
Yeah.
Is LoRA the only one?
LoRA might be the star of the show right now,
Okay.
but there are definitely other exciting PFT methods worth exploring.
Okay, fantastic. Well, let's do it. So let's go beyond LoRA then
Yeah.
and venture into this wider world of PT.
Okay.
What other techniques are researchers exploring to make fine-tuning even more efficient?
One technique that stands out is something called adapters.
Adapters.
Yeah, imagine these as small, specialized modules
Okay.
that we can add into the existing structure of the LLM.
So instead of overhauling the whole thing, we're giving it these extra modules.
Right.
Kind
To
of-
kind of enhance its capabilities for a specific task.
So it's like we're preserving that original knowledge base, but we're giving it these specialized tools.
Exactly.
Okay.
And adapters are designed to be modular too.
Okay.
Meaning we can train different adapters for different tasks,
Yeah.
and then we can easily swap them in or out without changing the core model's weights.
So we're giving it like a set of tools
Yeah,
that it can use.
exactly.
Okay.
Now let's shift gears a little bit
Okay.
and explore another technique called prefix tuning.
Prefix tuning.
Yeah, and as the name suggests,
Okay.
it involves adding a special sequence of tokens, like
Right.
a prefix,
Okay.
to the beginning of the input text.
So we're giving it a little hint
Yeah.
before it starts.
Exactly. These prefixes act like a steering wheel,
Okay.
kind of subtly guiding the LLM towards the task that we want it to do.
So it's like all these methods are about finding ways to kind of fine-tune the model very specifically.
Right.
We're not making these big sweeping changes.
Yeah, just updating what needs to be updated.
Yeah, exactly.
And here's the remarkable part.
Okay.
Prefix tuning can get some really impressive results
Okay.
by updating as little as 0.1% of the model's parameters.
Wow, that's a tiny fraction
It's tiny.
of the overall parameter.
Exactly.
So it's finding those kind of pressure points.
Right.
Okay.
Now let's look at p-tuning.
P-tuning.
Yeah, so this one focuses on optimizing how the LLM actually represents the input text.
Okay.
We call these representations input embeddings.
Mhm.
They're kind of like numerical fingerprints that capture the essence of each word or phrase.
So instead of changing like its whole knowledge base, we're
Mhm.
just changing how it sees the input.
Exactly.
Yeah.
We're refining how it interprets the input to improve performance.
So each of these techniques has its own unique approach.
Right.
But they're all trying to kind of maximize performance, but minimize those costs.
Absolutely. And that leads to a really crucial question.
Okay, what's that?
How do all these different methods stack up against each other?
Yeah.
And how do they stack up against full fine-tuning?
Yeah, that's a great point because we've been talking about the efficiency gains.
Yeah.
But ultimately, we care about the results.
For sure.
So can they really compete with full fine-tuning
Yeah.
in terms of accuracy and performance?
Well, the research is really promising.
Okay.
And in a lot of cases, these PFT techniques can actually match or even surpass the performance of full fine-tuning
Really?
while using way fewer
So
resources.
it's not even just about making it cheaper or faster.
Right.
It's about unlocking even more potential.
Exactly.
Wow.
It's
Okay.
really cool.
So it's like we've been limited by these traditional methods,
Yeah.
but now we're breaking free.
Yeah.
Okay, so we've covered a lot of ground here
Yeah. We have.
in the world of PFT and all these techniques.
Right.
But let's take a step back and summarize what we've learned. Okay, so we've established that PFT isn't just something we talk about in theory.
Right.
It's something that people are using to actually fine-tune these LLMs.
Yeah. It's really practical.
Yeah, and it seems like there are a lot of advantages.
Definitely.
I think the most exciting thing to me is it seems like it's making these AI tools
Right.
more accessible.
Yeah. For sure.
Because before it was only people with tons of resources.
Yeah, exactly.
But this is making it so more people can experiment with it.
By reducing those computational costs,
Sure.
it empowers researchers and developers who, might not have those big expensive computers.
Right.
And it lets them experiment and fine-tune these models.
It's like we're giving people the keys to this really fancy race car that was locked away before.
A great analogy.
Okay, good.
And with this newfound accessibility,
Uh-huh.
I think it also raises some new questions.
Yeah, what are those?
Well, if anyone with a decent computer can fine-tune these powerful LLMs,
Yeah,
what does that mean for, responsible development and deployment of this technology?
that's a really great point, and we should probably save that discussion for another deep dive.
Yeah, for sure.
But today, I think we've done a really good job of just talking about PEFT and all the technical details and how it might change the future of AI.
Yeah.
So what stands out to you as, the key takeaway?
For me, it's just how creative and ingenious this is.
Yeah.
PFT shows how innovative the AI research community is, and it's a reminder that we keep pushing the limits of what's possible and finding new ways to make these tools more efficient and accessible.
It's been awesome exploring PEFT with you.
Yeah, this has been fun.
I feel like I've just scratched the surface.
Oh, yeah. There's so much more.
But I'm excited to see where it goes.
Me too.
And all our listeners out there, I'll leave you with this thought. As PFT keeps getting better and these LLMs become even more specialized, what kind of new things are we going to be able to do with them?
Right.
How are they going to change industries, solve problems, and make our lives better?
Yeah.
It's going to be really exciting to see what happens.
Definitely.
So keep exploring, keep learning, and keep diving deep.
Yeah.
And we'll see you next time.